Hi, class. So this is going to be a lecture on uniform circular motion, specifically the rotation angle and angular velocity, which is section or 6.1 in your book. So uniform. Trying my best with the stylus, but I want to make sure I am clear and write these out so they're decent lecture notes. So the first thing we're going to go over is the rotation angle. And we start out with just a circle. Yeah, try to draw a better one because it's going to be important. Okay. Now try one more time. That wasn't too bad. Okay, yeah, one more time. Okay, good enough. Okay, so we're going to have 2 points here, or on the outside of the line, or something like that. And we're going to have a angle. Okay, and we're going to have angle here. That's going to be theta. Angle theta. Okay, so then I can draw these a little bit different too. So we have angle theta, or actually we can say that's delta theta. Delta theta. And then, so this is going to be S there. So that's going to be the arc or the distance that we travel around the circle. So, yeah, that's going to be S. And then we also have R. So I can draw R in a different color. I mean, that's still black, but we'll just draw it in a different color. So this will be R. Okay. And so we can say that the change in S is going to be the change in theta times R. So, or the other way around, it's going to be the change in theta is a change in S over R. We can write that both ways. So we can, this is the way your book does it. So S over R, or we can write it the other way, which I kind of makes more sense to me. So delta S is delta theta times R. So as you can tell, the radius is really important here. So you should know from geometry that the circumference of a circle, which means if we go all the way around to the beginning, should be 2 pi r times the radius. So as the radius gets bigger, circle gets bigger, circumference gets bigger, linearly proportional. So we know that, so if we go all the way around, which is basically 1 revolution, then delta theta is going to be 2 pi r. If we go all the way around, is r. So then we can cancel these out, and that means 1 revolution is essentially equal to 2 pi. We call that radians. Oh, I forgot the in there. Radians. And then this is going to be real important for your problem. So I think you probably remember this from geometry. That's important to remember. So 2 pi radians, and it's just a unit. It's going to equal 1 revolution. And so when you say revolutions per minute and radians per second, I'll get to that when I get to the angular velocity after this. But this is important to remember for this rotation. And so that's also equal to, if you do it in degrees, it's also equal to 300 degrees. Okay. So really, that's most of what we have for rotation angle, and a lot of this is going to deal with angular velocity. So I'm going to go ahead and erase this stuff, and we'll do angular velocity next. I can probably keep that circle there. That might help us out a little bit. Okay. So angular velocity. Okay, so angular velocity is going to be similar from what we just had. So we had what I just erased was do this in blue, I guess. Okay, so delta S is equal to delta theta times R. Okay, so we're going to define something that's called omega, which is the angular acceleration. And that basically means how many revolutions or how fast it's going around the circle. So the way we define that, and that's going to, or it's basically how fast theta moves per second. So it's going to be independent of the radius, essentially. So we're just going to define something that's called omega. I'm going to do this slightly different color. So omega, and so that's the W looking Greek symbol. And that's going to be the change in theta or change in time. And so this is basically the angular equivalent to the velocity. But we also have the velocity. So that's how fast this angle here is changing. So there. So basically how fast it's revolving. But another thing is, so when you, in your questions, problems are if it's a wheel or something. So how fast S is moving out here is going to depend on the radius. So this is just how the omega is just how fast it's rotating. But how fast a certain point here, do this in a different color. How fast a certain point here, how fast this point goes from this point is going to depend on the radius. And the way we do that is, so the velocity is going to, and so this is our distance here. That's our distance, is S, delta S. So I'll do purple there. Or actually, I'm going to do red, since that's what I do. Okay, so the velocity is going to equal delta S over delta T. Nope. And that's just the same as like X or whatever distance is that. But we know that delta S is going to equal theta R over T. Okay. So, and we know that delta theta R is equal to omega. Oh, I forgot the delta T there. Okay, so we know that this part here is just equal to delta theta. So then that means V is equal to omega times R. And that's going to be one of our real important equations this week. And so another way to write that is omega, I'll write omega a little bit better. Omega is equal to V over R, the radius. Okay, so that's basically the rundown of angular motion, angular velocity. So one thing it'll want to do is you'll want to convert from, say, radians per second. So this will be in radians per second usually. So that's how you would write that. But you want to convert to revolutions per minute. So the way that you do that is, we know that 2 pi radians equals 1 revolution. So you say you have omega in radians per second. So we know that, and to convert that, we know that 1 revolution is equal to 2 pi radians. Okay, so then those cancel out. And so that's revolutions per second is just divided by 2 pi. But then we need to say RPM. So that's revolutions per minute, and that's what it's going to ask you. So then we need to convert from seconds to minute. So we know that there's 60 seconds in 1 minute. So then these seconds cancel out. And so then that's 60 over 2 pi RPM, revolutions per minute. So basically you have to take it, if you want to go from radians per second to revolutions per minute, you got to take it times 60 divided by 2 pi. And you can just go on, another way to do that is just to go on to Google or something like that and find that unit conversion factor. Okay, so that's a pretty simple rundown of angular velocity and rotation angle. And I won't go into solving problems on that, but hopefully that helps anyone who wasn't clear on this. Okay, thank you.